here, R is here. So R angle between them is theta, which means PR cos theta can be written as P dot R. Yeah. What was the equation?
So R and R will get cancelled.
R and R will get cancelled, but I don't. Intentionally I'm bringing in R, so I don't want to cancel it, right? Because I want to bring in a R here, so I don't want to cancel it. So this is a vector. Even though V is
so it's not R cap by R.
Scalar.
It's not at R cap by R.
R cap by R. R cap by R. See, R cap means unit vector in
Unit vector.
right? So how can you get unit vector? R vector by
R vector by R. R.
It's actually the same thing.
So you write that on the 4 by epsilon P cos theta R cap by R square.
But since this is in magnitude, I will just written it as magnitude. Then the PR cos theta becomes P data. So only the final step becomes vector. All these things are just magnitudes. That's why I am not writing all this. Okay, so this is another important derivation. So E due to electric dipole, similarly V due to electric dipole. Okay. Is this for equatorial line or axial line? Is this axial line? Is this equatorial line? Equatorial line is like this. Axial line is like this. What is this? It is a general point, right? It is applicable for everything, right? So that means from this I can derive it for equatorial or axial. So can you try yourself? So what will be the angle when it is axial line? So from here it is theta. So if it is axial line, what will be the theta? 0. It is equatorial 90. So substitute it here and tell me what is V due to V on the axial line and V on the equatorial line. Right yourself. Just doing everything. Right yourself.
Cos 0 is 1, so it will be kp by r square. Cos 90 is 0, so that means it will be 0. So, what is the physical meaning of this? If I say V on the equatorial line is 0, what is the physical meaning of that? What is V, by the way? Potential means how much work you have to do for 1 coulomb, right? So, how much work you are doing? 0. To push it on the equatorial line. Why? So, for the plus Q, you have to do some hard work. For the minus Q, you don't have to do any. The system will itself work. So, both are getting cancelled out. So, that means the work done is 0. Okay, that's the meaning of this. Again, it's a little bit ideal situation, but in reality, there will be some extra work. Okay. That's the physical meaning. So, take it down. The physical meaning of this is whenever you are pushing the charge in the equatorial line, the work done is 0. Sometimes what happens is, I've seen in some exam questions, right, what they say is, derive V due to electric dipole on the equatorial line. So if they say something like this, any idea how to do this? You can do that, but if they specifically say equatorial line, right? What they're expecting you to do is, instead of doing all these things, finding it for the general point, right? And then substituting this. What they're expecting you to do is take plus q here, take minus q here, and that's your A, that's your A, that's your equatorial line. So if I take a point here at a distance of r, so simply calculate the V1 separately, V2 separately, and then add it. What is V1 here? Can you do it yourself? What triangle will be this at any point? Isosceles, right? Because this and this are equal. So this is a point here, which means this angle and this angle will be same. So it's isosceles, not equatorial, right? So what will be V1? V1 is equal to KQ by this, right? R1. So it will be KQ R1. What is V2? Minus KQ by R2. But R1 is also equal to R2. So R2 can be written as R1, which means this and this are equal. So V1 plus V2 will be R1 is equal to R2, so it will be 0. So KQ by R1 minus KQ by R1, so it will be 0. So this is an easy way to do it. Okay. It's not given in your book, but sometimes they ask you in the exam like this.
So what if they ask you that
So doesn't matter how many marks it's, if they're asking like this, you can do it like this. They ask you for any general point, then you have to do it for sure.